Howdy Pre-Cal, we are venturing into chapter 7. This is our last trig chapter of the year. I hope you have been enjoying trig so far. This first section, this first part anyway, will be kind of just an introduction, and then as we get more into it in the next couple of days, we'll get more in depth with it. Just as a review, you've got on here your basic trigonometric identities. So we have the reciprocal identities, which I feel like you guys are pretty good with. We have the Pythagorean identities. That might be where a couple of you were a little bit weaker back in chapter 5. So if that's you, you need to get on top of learning these. We also have our even odd identities. Remember that both sine and tangent, those are odd functions. So when you plug in a negative angle measure, you're going to get out a negative y value. We learned for cosine that it was an even function, meaning that it was had symmetry around the y-axis. So when we plugged in that negative, it didn't affect our function at all. We have cofunction identities that we actually are just not going to pay attention to because they're not really going to help us out all that much. So if you ever want to look those up, you go right ahead. But we're going to skip those and move on to the next one. It says identities enable us to write the same expression in different ways, and we did this back in chapter 5. It says it's often possible to write a complicated looking expression as a much simpler one. It says to simplify trigonometric expressions, we use factoring, common denominators, special product formulas, and the fundamental trigonometric identities. So you're going to see a lot of algebra, you're going to see a lot of trig in this section. So example number 1 says to simplify our expression, and we have been given cosine t plus tangent t sine t. So I would ask myself, okay, well, what is something that I know? The first thing that I can think of is that tangent, which is the reciprocal function of cotangent, but tangent also represents sine over cosine. So that's actually where I'm going to start. So I'm going to keep cosine t the same. I'm going to turn tangent t into sine t over cosine t, and that is being multiplied times sine t. Okay, so before I can add these things together, I need to simplify this multiplication going on. So right now this is like a sine t over 1. So you know to multiply fractions, we're going to multiply straight across. Sine t times sine t is sine squared t. Cosine t times 1 is cosine t. So then the next step is, okay, if I'm going to add these, I need a common denominator. Right now, that first fraction is cosine t over 1, but I need it to have a common denominator, so I need the denominator to be cosine t, which means I'm going to multiply that in the bottom, but whatever I do to the bottom, I also have to do to the top. So I'm multiplying the top and the bottom of that fraction by cosine t. So now I have cosine squared t over cosine t plus sine squared t also over cosine t. Now that I have a common denominator, I can write this as a single fraction. We have a denominator of cosine t. I'm going to add those numerators together. So I have cosine squared t plus sine squared t. And I'm hoping that you recognize that as one of the Pythagorean identities that we had. It's the very first Pythagorean identity right there. That if I add the cosine squared t or x or whatever, plus the sine squared t or x or whatever, it's going to turn into a 1. So my entire numerator now becomes a 1, and my denominator is still cosine t. And hopefully you remember that 1 over cosine t turns into secant t. Those are reciprocals of one another. So we took cosine t plus tangent t sine t, and we have simplified it into just a single trigonometric function of secant t. So that's a lot of the goal of what we're doing in this chapter, is simplifying things. All right, so example 2, we are adding these two fractions. Probably we're going to need a common denominator. So we're going to need the cosine theta we're also going to need the 1 plus sine theta. So for the first fraction, I need the 1 plus sine theta, and if I'm going to multiply that to the bottom, I also need to multiply that to the top. So I'm multiplying numerator and denominator by 1 plus sine theta. Over here, with the second fraction, also need that common denominator, so I'm going to be multiplying both the numerator and denominator by cosine theta. So let's look at what we have. So right now I have a common denominator. I have cosine theta onto 1 plus sine theta. That's going to be the denominator for each of these fractions. So I'm just going to go ahead and write those down. Now let's look at how we're going to change the numerator. So for the first one, we have sine theta, and I'm going to distribute that to the 1 plus sine theta. So I'm just going to take this sine theta and distribute it. And so that gets me a sine theta plus sine squared theta. So hopefully you're following me on that. I just did the distributive property. For the second fraction, we just have cosine theta times cosine theta, which is going to give us cosine squared theta. So now that we have a common denominator, I can write this as a single fraction of that common denominator. So there's my denominator, cosine theta, onto 1 plus sine theta. And now my numerator, I have sine theta plus sine squared theta plus cosine squared theta. Hopefully you notice this guy right here. He seems to show up a lot. Remember, we just saw that that was the Pythagorean identity that equals 1. So now my numerator is sine theta plus 1 over my denominator of cosine theta onto 1 plus sine theta. And at this point, you might be noticing that the numerator and denominator have the same factor, because sine theta plus 1 could be rewritten as 1 plus sine theta. Commutative property says it doesn't matter what order we add in. So those factors cancel out, but I can't have nothing as my numerator, so I still have a 1 there. My denominator is now cosine of theta, and 1 over cosine theta turns into secant theta as our final solution. So again, we had some practice there of having to find a common denominator, then adding our fractions, and then continuing to look for identities that we have been learning about since chapter 5. All right, next example says to write the trigonometric expression in terms of sine and cosine and then simplify. So in other words, make everything in terms of sine or cosine and then see what you can do to simplify it. So sine x is already a sine, but what do we know about secant? Well, it's the reciprocal of cosine, so we're going to have 1 over cosine x. All right, since that's multiplication, you're just going to multiply straight across. The sine x has a denominator of 1, so if I multiply straight across, I get sine x over cosine x. And what do we know about sine x over cosine x? It turns into tangent of x. And that is as simplified as you can take that. All right, same directions for part B. So we already have sine x. We also have cosine x. What do we know about secant x? Well, we just said that it is the reciprocal of cosine x. Now notice that all of these things are being multiplied together. And you may notice that there's a cosine x in the numerator as well as 1 in the denominator, which means that it cancels out. And we are left with just sine x. Those are pretty easy, I think. All right, example 4 says write the trigonometric expression in terms of sine and cosine and simplify, so same directions. So secant of x, we would turn that into 1 over cosine x. Cosecant of x, you might remember that that is the reciprocal of sine, so I'm going to turn that into 1 over sine x. So I've started off with a complex fraction. So I have 1 over cosine x. I'm going to change division to multiplication, and I'm going to change this fraction to the reciprocal. So remember, I'm changing dividing into multiplying by the reciprocal. So I'm going to multiply by sine x over 1. If I multiply straight across, I get sine x over cosine x, and that simplifies to tangent x. And that's our final answer for A. All right, so for B, again, following the directions, it says change everything to sines and cosines. Well, cosine squared x is already good. I need to change that tangent squared x. So I'm going to change it to sine squared x over cosine squared x. And then I'm going to take the cosine squared x and distribute. So cosine squared x times 1 is cosine squared x. What happens when I distribute it to the second term? You may have guessed that this cosine squared x is going to cancel out with this cosine squared x because this one is in the numerator and this one is in the denominator, and that leaves us with just a sine squared x. And you might recognize this one. Hopefully you do. That turns into a 1. That is that first Pythagorean identity that we learned. All right, so in this section, it's all going to be about proving what we call trigonometric identities. So we have some tips. It says start with one side. It's usually easier to start with the more complicated side. So typically, whichever side looks harder, that's the one you want to start with. Then it says use known identities. Again, taking you back to this very first sheet. All of those identities, you need to know them by heart because they're going to be what helps you get through this section successfully. So you've got to know those. So it says use those known identities. Use algebra, which is what we were practicing doing, and the identities that you know to change the side that you started with. Bring fractional expressions to a common denominator. We've already practiced that. We may have to factor and use the fundamental identities to simplify expressions. So we're going to be using a lot of algebra here with those identities that we've been working with since chapter 5. And then step number 3 is kind of if you have no idea what else to do, then convert to sines and cosines. It says if you're stuck, you find it helpful to rewrite all functions in terms of sines and cosines. So do you have to do it that way? No. If you can think of a faster way, by all means do it. This way is just if you're stuck and you have absolutely no idea what to do, it's worth a shot trying. So it's kind of like a last ditch effort, if you will, sometimes. All right, so example number 5, we're getting a taste of our first identity. Identity just means something that's true. It means that the left side and the right side of the equal sign, they are equivalent. They equal one another. So our goal is to prove it. That's what it means when it says verify the identity. So it says start with one side and that it's easiest to start with the more complicated side. Well, obviously this side looks more complicated on the left than the right side. So I'm going to start over here. And I'm just going to start by distributing. I think to me that seems like a route to go. So I have cosine theta times secant theta minus cosine squared theta. Okay, and then I put equals, and I'm going to leave this blank over here because I already know what that is, but my goal is to make the left side look like the right side. All right, so I have cosine theta times secant theta. Well, we've seen today already secant theta enough to remember that it is 1 over cosine theta. Remember, it's the reciprocal function. So if I multiply cosine and its reciprocal together, what happens? Well, they cancel each other out, leaves us with a 1. So we have 1 minus cosine squared theta. Okay, you might be wondering, what do we do next? Notice that we have this on this side, on the left side, and we're trying to get it to be equal to sine squared theta. So my mind automatically goes back, I'm just going to write it over here, to the first Pythagorean identity that we learned. So sine squared theta plus cosine squared theta equals 1. Well, if I wanted to get sine squared theta by itself, I would subtract the cosine squared theta. over to the other side. So I would end up with sine squared theta equals 1 minus cosine squared theta. So what do I now know about 1 minus cosine squared theta? It equals sine squared theta, which is what is on the right-hand side. And so I have just verified my identity. So I've taken the steps that I've needed to get both of these sides showing that they are equal to one another. So it's all about using algebra, using your identities, manipulating things to get it to look like what you want. All right, so example 6, we're going to verify this. You might agree with me that it looks like the right side is more complicated than the left side. So that's where I'm going to start over here. All right, so it looks to me like we probably are going to need a common denominator. So the common denominator, I'm going to need one of these, the 1 minus sine x. I'm also going to need one of these, the 1 plus sine x. So real quick, let me just write that common denominator because I need one of each of those. So that'll be the denominator for my first fraction. It's also going to be the denominator of my second fraction. All right, so the first fraction had a numerator of a 1, and in order to get the common denominator, I needed to multiply 1 plus sine x to both the numerator and denominator. The second fraction had a numerator of a 1, but to get the common denominator, I needed to multiply the top and the bottom by 1 minus sine x. All right, so let me write out my denominators again real quick. So in fraction number 1, I'm going to distribute the 1, which just means it doesn't change it, right? So I have 1 plus sine x as the numerator. In fraction number 2, I'm going to change this minus to plus, add the opposite. So I'm going to change that positive 1 to negative 1, and I'm going to distribute the negative 1. So I get negative 1 plus sine x. How are we doing so far? Hopefully everybody's doing pretty good. So when I go to combine these into a single fraction using that common denominator that we have already come up with, what happens to the positive 1 and the negative 1? They cancel each other out. Sine x plus sine x turns into 2 sine x's. Now let's look in that denominator. What happens if I were to maybe FOIL that out? Let's FOIL it out together. So if I did first, I would do 1 times 1, which is 1. Then for my outer term, I would have a positive sine x. For the inner term, I would have a negative sine x. And for the last term, I would have a negative sine squared x. What happens to the 2 in the middle? They're opposites. They're going to cancel each other out. So I still have 2 sine x as my numerator. Let's go back and talk about this denominator for just a minute, and I'm going to go back to that first Pythagorean identity. Right here I have 1 minus sine squared x. So if I were to move that sine squared x over to the other side, what's left? Well, we now know that 1 minus sine squared x is the equivalent to cosine squared x. What if I put that down here? I'm substituting it. So I'm taking 1 minus sine squared x out. I'm putting cosine squared x in its place. Well, what does it mean if you have something squared? It means that you have 2 of them, right? So I have a cosine x times another cosine x. That's what it means to have something that's squared. Hopefully everybody's okay with that. I just took this and broke it apart. Now look at the way that I have it written. I have 2, then I have sine x over cosine x. What does this turn into? Remember, that's going to be tangent x. Back here, I have nothing, which is the same thing as having a 1 over cosine x. What do you recognize that as? You might recognize that as secant x. And now we have exactly what we had on the left-hand side. And so we have verified that identity. So it's a lot of manipulating things to get it to be how you want it to be while remembering all the identities that we have been learning about. All right, so last one for today's examples. I'm going to start on the right side because it looks like it's a little bit more challenging than the other side. And I'm going to start off with rewriting those. So secant of u, that's the same thing as 1 over cosine u. Tangent is the same thing as sine over cosine, so I'm going to have sine u over cosine u. One thing I want to just remind you of is don't just write sine over cosine. You have to include whatever that variable is, whether it's an x, a t, a theta, a u. Make sure you include that. All right, so I've got a common denominator, which is great news because now I can put these together as a single fraction, and my numerator is going to be 1 plus sine u. The problem is it doesn't quite look like what I want it to look like. So you might remember, and I can't remember exactly which chapter it was, but we learned that sometimes you have to multiply things by the conjugate. Remember, conjugate is when you take a binomial and all you do is change the sign in the middle. So the binomial that I currently see right now is 1 plus sine u. Its conjugate would be 1 minus sine u. But if I multiply that in the numerator, guess what? I have to do the same exact thing to the denominator. So let's just try that because sometimes we get to a point where it's kind of like we've hit a brick wall and maybe this option would help us out. So in the numerator, let's FOIL this guy out together. So 1 times 1 is 1. For outer, we would get a negative sine u. For inner, we would get a positive sine u. Well, what's going to happen to those two things, outer and inner? They're going to cancel each other out, so I'm not going to write them down. For last, I'm going to get a negative sine squared u. Now, you might have recognized that that was a difference of squares, and so you could jump right into what that would look like. But if you didn't, foiling is fine. In the denominator, I have cosine u onto 1 minus sine u. All right, so let's see. This is where we are. This is where we want to be. We do have some good news. We already have the 1 minus sine u. The bad news is we don't want to have this cosine u. So let's go back and look at this numerator, this 1 minus sine squared u. You might recall that actually from example 6, except we had a variable x instead of u. What could we replace the 1 minus sine squared u with? We could replace it with a cosine squared u. So that's exactly what I'm going to do. Remember, I said it's all about manipulating the things that you know. We know the Pythagorean identity. We're manipulating it. We're changing it around to meet our needs. So I have taken out 1 minus sine squared u. I have replaced it with cosine squared u. Now remember what I said earlier. What does it mean if you have something squared? Well, that literally means that I have a cosine u times another cosine u, which means I can cancel 1 out from the top and the bottom. So now my numerator is cosine u over a denominator of 1 minus sine u, and that is exactly what we have the other side looking like. And so we have verified the identity. All right, so this week our goal is to continue to work on this, these types of identities. So tomorrow and Wednesday there will be new videos up, and it's just going to be practicing this where we're having to learn how to manipulate, use algebra, find common denominators, sometimes includes factoring. We're going to be practicing it a lot over the next couple of days. So it's really important that you stay on track and that you're doing your homework in a timely fashion. Again, I'm giving you odd problems because I want you to be able to check your answers and see how you're doing so that you can let me know when you need help. So the way that this week looks like it's going to work is that we have new videos both tomorrow and Wednesday. And then on Thursday, we're going to meet in a Zoom session and have a quiz just on this one section. So all we're focusing on all week is this section before spring break starts. So y'all have to let me know what you need help with as you come to it. And I look forward to seeing you guys at the next video. Bye.